Hi guys, so in this video what we're going to look at is what's called the Bernoulli trials, and they have to have a few things to be true if it's going to be a Bernoulli trial. So the first one is that they're independent. We should know what that means now, that one of these is not going to affect the other. They're identical, so we set up a system. So for example, tossing a coin, all we're doing is we just keep tossing a coin. It's exactly the same experiment. And each trial has only two possible outcomes, which we can term success and failure. So if I go back to that example of tossing a coin, they're independent because what one result does not affect the other. They're identical, it's just throwing a coin up in the air. And there's two outcomes, heads and tails, and I could say heads is a success, which obviously means that tails would be a failure in this particular example. Another example would be throwing a die and having 1 as my success, which means that all other numbers would be my failure. So the probability of a success in this particular case would be 1/6. Again, every time I throw a die, they're independent. It's an identical trial. There's two outcomes for this particular one where I've said I want a 1. 1 is my success, all the other numbers are my failure. And notice that the probability of the success and failure never changes. Okay, so let's have a look at repeated Bernoulli trials and the idea of keep going until you get your first success or your first failure. So the way we define this is we come out with a single Bernoulli trial has a probability of success P and a probability of failure Q. So what I'm going to do is I'm going to look at the die for my example to talk you through this. And I'm going to have the success as getting this a 6. So success, okay, is getting a 6. Okay, that means that my probability of success, i.e. my P is equal to 1/6 because there's 1 6 on the die, there's 6 possible outcomes, therefore 1/6 is the probability of my success. Now Q is the probability of failure, so Q is just 1 minus a sixth, so I end up with 5/6. And now I have my P and I have my Q for this Bernoulli trial, or this Bernoulli system. Okay, so the first thing we're asked to work out is the probability of the first success occurring in the nth trial. So suppose I wanted, say, instead of the nth trial, suppose I wanted my first success. Okay, so I want my first success in the 4th trial. So we'll go with the trial here. So that means I've got to have a failure, a failure, a failure, then a success. So F, 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 S, and remember that it's a failure and a failure and a failure and then a success. So remember that a failure is Q, so we've got Q and another failure, which is another Q, and another failure, which is another Q, and then we have a success, which is P. So hopefully you can see that this here is Q cubed followed by a P, which if you have a look up here is your Q to the n minus 1 because my number of trials was 4 multiplied by P. So Q cubed by P, and if we just do the maths there, we find that because my Q is 5/6, so this would be 5/6 cubed multiplied by P, which is 1/6, and then we just do the maths and find out what that is. For the second one here, where it's probably the first failure, it's just the opposite way around. So if we do again, so first failure in the 4th, we'll do 5th trial for this one actually. 5th trial, the numbers will be slightly different. That means that what we're going to get is we're going to get a success, a success, a success, a success, then a failure, which means we're going to get P by P by P by P by Q, and hopefully you can see then we're going to get P to the power of 4 times Q, so P to the 4 times Q, and again, if you have a look here, it's P to the n minus 1, my n here, my number of trials was 5, P to the n minus 1 is 4, and then Q. So that means that the probability of the first failure occurring in the 5th trial is going to be equal to, it's going to be 1/6 to the power of 4 multiplied by the failure, which is 5/6 in this case. Okay, let's have a look at another example here. So hopefully you can see where those formulae come from. So it says here, for a single trial P, the probability of success is 0.4. So if P is equal to 0.4, that means that Q is equal to 1 minus 0.4, which is 0.6. And I think that's just answered part I. It says if the trials are repeated, find the probability that the first success occurs on the 4th trial. So the first success on the 4th trial. Well, we've just basically done that in the previous slide. So that means we want 3 fails. So the probability of that happening is q cubed multiplied by p, which is equal to 0.6 cubed multiplied by 0.4, and that's equal to 0.0864. Okay, the second one then, oh, that is the second one, sorry. So the third one, the trials are repeated, put I there. It says, find the probability the first failure occurs in the first trial, in the third trial. So the first failure, so that means we want success twice, and then we want a failure at the end. So what we end up now is 0.4 squared by 0.6, and that's equal to 0.096, and that's basically that straightforward. So if we have a look at this formula, this will give us our successes in n trials, and what that means is, so if I go back to the idea of my die and my 6 being a success and everything else being a failure, what this is saying is, well, suppose I threw the die 6 times, what's the probability that I'd get 2 6s in there? Okay, so 2 successes. And it's just a very, very simple binomial formula for this. And how we'd set this up, I am actually going to just run you through that so you can see it. So using that example, that means if I want a 6 to be a success when I throw a die, we're happy that the probability of a success of that happening is 1/6, which means that the probability of a failure is equal to 5/6. So that shouldn't be an issue. The next thing we want to know is, suppose I want to know that the probability from, we'll say from 6 trials, so we do 6 trials, I'll just put 6 here for trials, and I want, of those 6 trials, I want to have 2 successes. So what I do is I say the probability that x is equal to 2. In the formula now, my n is the number of trials, so my n is equal to 6, and my r is the number of successes that I wish to have, so my r is equal to 2. And all I do now is I just put them into the formula that we have there. So you can see, I'm just going to quickly just rewrite the formula. What we have is P of x is equal to r is equal to nr, that's the combination of p to the power of r q to the n minus r. So just stick in the numbers. So in this case what we have is the probability of x is equal to 2, i.e. I want 2 successes, is equal to n, choose r, my n is equal to 6, there are 6 trials, I want 2 successes. The probability of success is 1/6. I want r is equal to 2. The q here is 5/6. And then what I have is n minus r. Well, my n is equal to 6 minus, and my r is equal to 2. Okay, if I work that out, I get 6, choose 2, I get 1/6 squared, and I get 5/6 to the power of 4. Notice, guys, you'll know if you've got this right. You can see here that this will always go up to here. So notice how my r will always go on to the top here, and the 2 and the 4, which is the indexes or the indices, will always make the 6 here. Okay, you then get your calculator out and you work out what that's going to be. And in this particular one, it's 0.2009 to 4 decimal places. Okay, so let's have a look at another example of this. One's a little bit more technical. So it says on this slide, it says a die is thrown 8 times. What's the probability we get at most 2 6s? Okay, so the first thing here is we have to work out the probability of success and the probability of failure. So for one iteration, i.e. one trial, my p is equal to 1/6 here, which means that my q is equal to 5/6. So the success criteria is that we get a 6, which means our failure is 1 minus a 6th, which is 5/6. The formula, if you remember rightly, is P, x is equal to r, is equal to nr, and then what you have is p to the power of r, q to the power of n minus r. And we have probability that we get at most 2 6s. So at most 2 6s, which means we can get 0 6s. So what we're working out is the probability of 0 6s, or the probability of 1 6, or the probability of 2 6s. Okay, so that's what we're trying to work out. So it's 3 things that we have to work out here, and we're going to have to throw everything through this formula 3 times, changing our r as we go along. So for this one, my n is equal to 8, That's not going to change for any of these. My r is going to be equal to 0 because I want 0 sixes. For this one here, my n is going to be equal again to 8. My r is going to be equal to 1 because I want 1 6. And this one is my n is equal to 8 and my r is equal to 2 because I want 2 sixes. And then I'm going to work these out separately and then add them together to get the answer. So this one here is exactly the same. It's probably that x is equal to 0, or the probability that x is equal to 1, or the probability that x is equal to, in this case, to be 2. So if x is equal to 0, let's go through the formula from up here. Let's just put in what we know. So the first one then is n, r. So n choose r, so we've got 8, choose 0. We then have our p, which is 1/6, to the power of our r, which is 0. We then have q, which is 5/6, to the power of n minus r, and 8 minus 0 is 8. The or in maths means plus. I'm going to run through this second one now. So what we have now is 8 choose 1. My r is equal to 1. Okay, and that's going to be now a 6th to the power of r, which is 1, multiplied by 5/6 to the power of n minus r, so that's 8 minus 1, which is 7. Or, and let's run the next one, 8, choose 2 this time because the 2 there. We now have a 6th to the power of r, which is 2, and q, which is 5/6 to the power of 6. And all we do then is we work each of these out separately and add them together. So if we work out the first one, it's going to be 0.23257. Okay, plus the second one, stick it in your calculator, is 0.37211. Plus the last one here is 0.26048. Add them together and you'll get the answer of 0.86516. So what we're saying is, if a die is thrown 8 times, the probability that we get at most 2 6s is 86.5%. Okay, the last one. It says here, fair die is thrown repeatedly. What is the probability that the third 6 occurs on the 8th throw? So the third 6th occurs on the 8th throw. I'm going to give our answer to 3 decimal places. So I want to find out the probability that the third 6th occurs on the 8th throw. Okay, let's go to the side again. We know again that p is equal to a 6th because the probability of getting a 6 is 1 in 6. That means that the q is equal to, and this time what we have is the q is equal to 5/6 as before. Now, if the third 6th occurs on the 8th throw, that means that the other 2 6s must have occurred in the first 7. So what we have here is we have essentially 2 successes in the first 7 experiments or trials and a success in the 8th throw or trial. So that's what we have. So you can see here what's happening is this here is the binomial bit. This is the bit where we're using the Bernoulli. And success in the 8th is, well, we've got an and here, which means we're just going to multiply it by the success in the 8th, which is just a 6th. That was easy. So what we want here is we want the probability that x is equal to 2. So we want 2 successes in the first 7 trials followed by success in the 8th, which will give me the third success. So you can see the third 6th, which occurs on the 8th. So the probability of x is equal to 2. And you can see here our n is equal to 7, is what we're going to be throwing through our Bernoulli or our binomial expansion here, or my binomial distribution. Okay, so x is equal to 2, so let's work that out. That means we have n, which is 7. Our r in this particular one is 2. We then have our probability, which is a 6th. The power of r, which is squared, multiplied by q, which is 5/6, to the n minus r, which is 7 minus 2, which is 5. But then we also have this and bit, because we need the success in the 8th one, so we need to now multiply this by the 1/6. So let's do that. So we multiply that by the 1/6, and I'll just leave that in red. So times by this 1/6 here. And hopefully you can see this is the same as 7. Choose 2. 1/6 squared times another 1/6 is 1/6 cubed. So 1/6 to the power of 3 multiplied by 5/6 to the power of 5. You get your calculator out, stick it in, and if you do that, you get 0.039 to 3 decimal places. That's equal to 0.039 to 3 decimal places.